Good afternoon. I'm Dan Bandera. I'm the president of the OSGi Alliance, and welcome to this session. We don't have a title slide, so I'm just going to read it off. The OSGi creates real technical added value in IoT. Let's talk about concrete use cases. If you're not here for that, this is time to get off the plane. So what we're going to do is, this is a panel session of subject matter experts, people who deal with OSGi in the IoT environment, and I'm going to kick it off with a couple of questions, and then we're going to turn it over to you folks to ask questions. And I can run around the room with this thing so that everybody can hear. So introduce yourselves, please. I'll start with you.
Okay. Yeah, hello, my name is Jürgen Albert. I'm CEO of Data and Motion Consulting GmbH. We are OSGi Alliance members for 3 years now, I believe, and yeah, work basically with OSGi for 10 years.
Hi, my name's Tim Ward. I'm the CTO at Paremus. I've been with the OSGi Alliance again for about 10 years, and I'm also co-chair of the IoT expert group at the Alliance.
Yeah, hello, my name is Kai Hackbart. I'm an evangelist with Bosch Software Innovations, and I'm with Dan on the board of directors of the OSGi Alliance.
Hello, I'm James Hunt with ICAS. We have a real-time Java implementation, and we joined the OSGi Alliance about a year ago, and our goal is to bring real-time into the OSGi Alliance because we see that as a major enabler for IoT.
I'm Bruce Jackson, CTO at ThingStream. I'm also co-chair of the OSGi IoT experts group.
And I'm Kristi Larson from Makewave. I've been around quite some time, almost as long as Dan, or more or less that, which means 20 years. I come from a company called Makewave. We are perhaps more or best known as the implementers of Noplefish, the OSGi stack.
Thanks, gentlemen. So I'll kick it off, like I said, with a few questions and get some of the answers. You guys pass this, or I can give it back to you. And if the audience, when we get later, I'll run the mic around. So you probably saw this in the write-up. What are the technical challenges, and how did OSGi help to overcome them? Who would like to start? I think, Kristi, maybe you could, because of where we started.
Where we started 20 years ago. Yeah, if you go back 20 years ago, OSGi was designed to as a platform or a runtime environment for embedded gateways, or residential gateways, and the target was really the smart home, which was way ahead of its time. We had great concepts, but it was way too early. And the problem we solved is to get this uniform platform, this uniform execution environment on the residential gateway, make it secure and make it remotely manageable. And those three important factors still apply, especially in the IoT market.
You get started if you want.
So we've been in the automotive industry for quite a while, and we launched a platform for infotainment and telematics that's been shipped on 5 million vehicles at this point. And originally we did our sort of roll our own kind of thing, and the ideas was you can run multiple apps in a single VM space, and they could talk to each other, but you could update them individually. And eventually we came to the conclusion that having a more solid basis like OSGi, which was well-defined and had additional things like resolution and versioning would be a big help to our market, and that's why we've moved to OSGi. On the other hand, because we come from a real-time Java world, we've brought with us things that we think that OSGi could benefit from, like real-time capabilities and resource enforcement, to be able to actually say, hey, this bundle's running amok, I can kill it, I don't have to wait for it to stop. So that's why we think OSGi is a good place to do that.
All right. So, I mean, we as Bosch Software Innovations and formerly ProSys, we have our own OSGi IoT stack, right, for embedded devices. And so I was co-chair of the residential expert group, and I think two major things that we were trying to solve back then was the fact that there was no standardized way of managing your devices, in the homes, specifically back then in the homes, in a standardized way. So we worked together with, for example, the Broadband Forum, with other organizations to find a standardized way that was specifically designed for the telecommunications operators. And on top of this, what we did is also we were attacking this connectivity issue, right? So I mean, there are tons of different protocols out there, and I mean, there's a reason for that. And sometimes, you may just need one, but in several cases, you will probably have several protocols that you need to support. And so we worked on, for example, ZigBee and other protocol adapters. And on top of this, the device abstraction layer, which basically helps you to take away the pain for the app developer to talk to the device. I mean, he just simply wants to turn on, let's say in a simple case, a light bulb. And it doesn't matter to him if it speaks Bluetooth, Z-Wave, or whatever other protocol, right? And we take this pain away with OSGi.
Anybody else want to comment on that question?
I'd like to comment. Yeah, like I said, we work with OSGi for like 10 years now. We started out with Eclipse RCP. And at a certain point, we need communication with a server. So we found a server which was OSGi capable at the time. And we stuck to it since, because we always saw how good everything works together. And the more we dove into the different specifications over time, the more we could throw out our own implementations for something, because for most things for 90% of the things you usually use in whatever solution, whatever industry you're working, OSGi already has some kind of a simple mechanism to do it for you. So, and by the end of the day, we now have done projects in medical, in transportation, in traffic, in smart city projects. So many different kinds of projects with many different applications. And OSGi never let us down and always kept things manageable and kept us ahead of everybody else working on similar projects.
I was going to say something that's not really related to technology, actually, but that is a side effect of working in OSGi for some period of time. And that's the way that it changes your thinking about problems. When you work with OSGi, there is a natural everything becomes very much more modular, or you're made to think in a way that's more modular, and you're made to think in a way that abstracts services from implementations. And that general practice is super helpful, regardless of how it's implemented. That way of thinking about things ends up being something that you find improves the efficiency of your organization and your ability to solve problems in a general way. So it's not just about the technology, which does have all these benefits, but it's also just the way it changes the way you think about how to solve problems too.
So just to round things off, Paremus have been using OSGi for a really long time, and we actually started in the enterprise space, so nothing to do with IoT, and using OSGi as a way to scale out and deploy large-scale distributed applications. And it turns out that in the last 20 years, moving large-scale distributed enterprise applications across large numbers of computers looks an awful lot like what has become IoT. It's just now we have lots of small devices talking to this large number of computers that are taking input, rather than business machines. They're just devices providing data or that we're controlling. And it's amazing how flexible the OSGi model is, because you have these bundles that you've created that do something, and it turns out that even if the world is changing around them, if you need that piece of function, you can still use that same OSGi bundle. And you might need to put some kind of other adapters around it or have other input processing coming in. But because you have these reusable chunks of function and these evolvable chunks of function, you're able to take things that have been written 20 years ago and still get use from them and still adapt them into the new world. So it's fantastic to be able to look back at our code base and see how things that were written with no idea that they were ever going to be used in an IoT scenario have evolved from that of the very first commits. And you can still see that a lot of them don't look that different. So I think it's an unsung power of OSGi that you've got the ability to evolve what you've written over time because these modules are independent and loosely coupled.
That's interesting because you see I'm at the edge. He's in the cloud. We're using the same platform. That means that you have a very large freedom of choosing where what computation happens. So if you have weak devices, you can move the computation to a gateway. If you have strong devices, you can put more computation on the device. And this is a very powerful thing because you can move anything between the cloud and the device, and it just works.
Actually, as moderator, I'm going to talk about this because I think you were part of the project, Krister. Back in the early days, when we were first doing gateways, the hardware price for what you could now buy for 150 euros was like 3,000 to 4,000 euros when the OSGi Alliance started. And so one of the projects, which goes to James's point, was you couldn't afford to put them in a bunch of homes, and there was an experiment that one of the Scandinavian telecommunications companies was doing, and they couldn't afford to deploy $4,000 boxes in every apartment that was in this apartment complex. What they did is they put it in the central office, okay, and they virtualized the services, and they pushed it into they use OSGi bundles in the central office. As prices came down, that could get moved. Now that it's 120 euro, you can run that exact same stuff down in that box. So it really does give the flexibility and power of OSGi. And when you said that, I just remembered this experiment that we did, and it was the predecessor company to Makewave, GateSpace, that did that experiment. Anyway, I think we're done with that first question. So, and actually when I look through these questions, you've touched on many of them. So I'm going to skip to what do you think is the future of OSGi and IoT? Because we came from IoT, we're going back to IoT in many ways. What do you think the future is? Where do you think we're going to see our stuff next? I know you all work on different projects, so why don't we, Kai, you're holding the mic, why don't you?
I mean, so when I was processed, I mean, the domain we were mainly focusing on was smart home. So we worked with, lots of different companies from Bosch to Deutsche Telekom to Devolo and so on. So you find, lots of OSGi-based smart home systems. And with the Bosch acquisition, this focus actually has, changed quite a bit. So we do have projects now in, what we call in Germany Industry 4.0 or IIoT, right? So we put our OSGi stack in industrial PLCs. So I absolutely see, like what James said, the need for real-time Java OSGi-based environments. So we will see this definitely, and it will also open other areas for OSGi where this might be applicable, for example, in vehicles when we talk about autonomous vehicles and so on, right? And top of this, we have other use cases in agriculture, for example, where we have systems that are deployed in farms to monitor temperature, humidity, and to basically forecast, when these plants could potentially become sick of something. We deployed it to oyster farms, so that's one of our favorite projects in Australia, right? So we basically monitor the saltiness of the water and many different things, and there is an OSGi-based gateway that sends data via LoRa to the cloud and to analyze and predict, for example, when is the best time to harvest the oysters and to avoid loss, yeah, because if it rains, yeah, the oysters could, potentially be poisoned, and you can basically just, throw them away. So there are many different areas, and as I said, so real-time Java is for me one of the things that we need to work on.
So I think one of the things that we've sort of alluded to already is the fact that with OSGi you can deploy the bundle that you've written in a lot of different places. You can have it running in the cloud core, you can push it all the way out to the edge, potentially even run it on the device itself. And I think that one of the things that we will be working with, certainly in Paremus and I think across the industry, is we're going to have to do a lot more work layering the systems that we build. So there's a lot of talk in 5G about trying to get to sub-millisecond latency for, you have a device that is sending data and you want to be able to take that data, process it and react to it, and then maybe have a response that's happening in under a millisecond. So for industrial control systems, for autonomous vehicles, for things where safety is partly determined by how quickly you can react. Now, OSGi gives you the ability to take functions that need to react quickly and put them physically close to the places where the data is coming. Because one of the things about 5G and the sub-millisecond latency is that it's great, it can give you that, but it can only give you that over certain distances, because the speed of light is a constant, right? If you've got a process in the cloud that's in the USA and your car is driving in Europe, if the signal has to bounce there and back, there is no way you're getting sub-millisecond, no matter how good your routers are. So instead, what we need to be able to do is to take our sensor devices and have them communicating with local fog-like cloud infrastructure, which can be using OSGi, and deploy the necessary bundles to handle the things that are connected to it at the time. And then have a cloud core which is capable of doing maybe longer term processing of archived data, so proper big data processing, machine learning processing to maybe get long-term high-level trends, but to have that local deployment of functions that are doing processing for what I like to call autonomic reflex behaviors. So it's like the reflex where you hit your knee and you kick. So that signal never makes it to your brain. It's processed by your spinal cord quite low down. The signal goes from your knee to your spinal cord and then back and makes you kick. It never actually makes it to the central processing area. And we need exactly that sort of behavior to make IoT systems really work. They're just not going to work if we try and make everything go back to the brain. We need the whole system to be aware of what's happening and able to make changes based on what's happening around it.
So we're already using real-time Java for machine control, so low-level machine control for autonomous driving. We have a partner that's riding around in the roads of Maryland and other places with autonomous vehicles based on completely on real-time Java. But if you look at IoT, what the big buzzwords are data collection and AI. Well, say one thing to that. One is if you have neural networks in your system, they will be better tomorrow than they are today. And the state of the art will be to keep them up to date. So you need a platform like OSGi to do that. So you imagine millions of cars on the road running an AI system for autonomous driving, and somebody finds there's a bug someplace. Well, how fast do you want those things updated? Immediately, right? Well, this is one of the ways you can do it. And having OSGi not only be able to manage itself, but other things in the vehicle or other things in the factory will be a huge win for OSGi, and I think that's one of the ways we're going to it. But the other thing is, of course, real time has to be part of that thing. But if you think of digital twins, OSGi is also a good platform for that because you can run the same software in simulation environment that you run in the car. So you really can test it out in a very deep way. That's not so easy with other technologies.
A lot of very good things have been said already. I just want to comment on a few things. That from a Makewave perspective, we found out that by having an OSGi platform out there, it provides a very nice uniform layer. So any kind of business logic or control layer you want to have on your devices, make them in OSGi. And the same bundle can run regardless of generation of platform, et cetera, et cetera. But you keep the lower layers typically native, or you can use Realtime Java. You, of course, have the two options. And also want to comment on what you said about having the twin environments, that if you do something with fleet systems where you have devices going around out there somewhere in the field, far, far away, they might not be connected, they might not be always on. Being able to resolve beforehand and making sure that what you're going to send down actually is going to run out there is crucial. And also when you make an update, always make sure that you have a fail-safe procedure, so you can always roll back to the last known good configuration you had on the device.
So just one small thing from my side regarding the question where the future of OSGi and IoT is. Actually, I think OSGi should be everywhere. Java can go and even basically beyond, because with all the things we already said, so it gives you all the tools to resolve things, to distribute, to communicate, and to keep up with the flexibility the world around us requires from us. So.
To add from my side, so I mean, so the future is one thing, but I think we should also talk about what we have achieved in the past, right? So I mean, there's the specs, that's one thing, so that, you know, what we collectively did in the OSGi Alliance, and you heard James deploying, you know, the technology in, you know, millions of vehicles. So we at Bosch, we also, you know, as I said, Deutsche Telekom is you know, one of our customers. They basically put our OSGi stick in every router. Yeah, that's a couple of millions per year that they, you know, ship. And if you think about also, you know, the various open source projects, yeah. So there's so much OSGi technology out there, yeah, today. Especially in the edge, I would say. I mean, in the context of IoT, yeah. And I think that what we are currently facing, I mean, with the fact that IoT is, you know, such a fashion now that everybody wants to do IoT, is, you know, we have a huge fragmentation, yeah. And I think that's, you know, where we at least here jointly together, yeah, basically, you know, have a, you know, one approach, yeah.
It sounds all great, but let's pretend I'm an IoT vendor and I really would like to get started with this OSGi stuff. What is the best place for me to go first if I want to learn about how to use OSGi for my IoT applications?
Give it to you, and who was
So I think you've been good in that you've given sort of as a vendor, but are you talking about the vendors of devices, or are you talking about a vendor who is looking to provide a platform to which devices are connected? Because they're slightly different things. So if you're looking as a vendor and you're looking to build a platform to which devices are connected, so say you want to start putting together your own home gateway, or you want to start putting together a cloud platform that people can sync their devices to and use to see, you know, that from their doorbell that has a video connection, they want to be able to watch that on their phone when someone comes and rings the door when they're away. So for that, I would suggest that the things that are already available from OSGi en route is your best way into OSGi. So it gives you a really simple way in to learn about the kind of basic specifications that we would recommend that pretty much everyone use in order to build simple applications to start with, so that you start building things in the right way. So we heard earlier about the OSGi mindset and how it changes the way that you think about problems and the way that you build solutions. So one of the problems people find they have when they first come to OSGi is that you don't have that yet. You haven't learned it, and that's okay. You know, it's not the way that everybody thinks instinctively, but it means that you will also have a habit of going at it in a way that doesn't naturally fit with what OSGi provides. So I can recommend, and Dan, if you're looking to write up the URL, it's enroute.osgi.org. And so that's a great place to go for learning about OSGi from scratch. It's even useful for people who do know OSGi and maybe want to see about how things are done with more modern versions of the specifications than maybe they've used before. So that's one piece. If you're looking at coming at it from a device vendor perspective, really there, probably what you're looking to do is to provide ways of accessing your device in OSGi. And at that point, you're probably more interested in some of the specifications that are available on the web. So we have HTML versions of all of the specifications. They're designed to be human readable, which is not the case for most specifications out there, I can tell you. So you would be able to do something like look up the device access specification, look up how we do things like, so maybe you're using using CoAP to communicate with your device, and you want to be able to supply your own URL handlers. The specifications are there, and they're an excellent resource, and I would recommend that people do go to look at them if they have questions, because they do provide answers in a way that's designed to be understandable by normal human beings, and the specifications all contain examples as well of how you use them. So hopefully that has answered that question, and I'm aware I've been talking for a while, so.
Okay, so keep that one up front. Now, I'm noticing the time. We have about 8 minutes left. So we have time for the audience to ask questions. So way in the back.
This might be a tough one, because I know I've talked to a lot of you about this recently. So I think there's a little bit of an issue in the industry in the sense that the goals that, or the design patterns and the solutions that OSGi have been bringing are very trying to be based on a calculable result set, right? Something you can measure, a metadata that can be calculated, and you can reason, a machine can reason over it, right? And so it's a restriction, and yet it's with a certain particular goal in mind. And yet another entire part of the industry is trying to shed any kind of restrictions on the development process, and it's moving very, very quickly. So how do you think OSGi should deal, or what approach do you think it should take to try to, I don't know if it's called educating, and I think it's kind of educating the industry on software development and engineering in particular, because it's really more of an engineering methodology. You're building something with some constraints, and some of those constraints are maintainability and reliability and durability over time and security and all these things. And you put those are restrictions that are quite heavy. How do you think you compare against, or how do you think you compete or you educate this, against this other side of let's just build it because we're going to throw it away tomorrow?
Yeah, I think that's, like you said, it's a tough question, because these are two really, really fundamental mindsets. And I found out, I've seen that many people, or many people that want to have the other side you've mentioned is this, oh, I want to be open. They usually underestimate the reality they are living in. So, and this is hard to change, because OSGi expects you to solve think about your problems ahead of time. So, and it does it in parts for you, but it still says, okay, a complex system is a complex system. I just help you manage the thing. So what I think, what might help people that want more liberty there could be, so this is my personal point of view, if we have a lot of specifications which are not really bound to Java. So there should be, or it would be great if we would have more implementations for different programming languages, for example. Everybody in the world is now currently crying for, whoa, we want to do something with JavaScript, with TypeScript and whatever, so there's a big community there. So yeah, let's come up with a framework implementation for this, remote services, and enabled for other programming languages. So I know in parts this is out, and there are solutions there, but this is something when you show people, okay, you can go your way, but you can use in your programming language and in your ecosystem, you can use OSGi, and it really solves problems for you, then you get people on your side. So this might help the process.
Now you challenge James.
Of course, it also might hurt. So one of the things that Java brings is it's a managed language. It's a very stable language. Now, of course, it's a VM. I can run Scala. I can run other languages, interesting languages too, but I'm not going to run C++ on the VM. And you know, there's limits to what OSGi can reasonably do in that direction. Although you can say, okay, I can build things and distribute using the OSGi packaging and things, and there's room for that for smaller parts of the system. But the problem with unmanaged languages is they break easily, and they are not manageable over a long term. And you see that over and over again. You know, if you get some C code to run, if you change it, you're going to spend months debugging it if it's at all complex. In Java, you have lots of capability to see what the error was, to locate it, to understand it, and that you just don't have in those other languages, and that's because it's just a much robust language. And the other thing about Java and about OSGi in particular is they're very stable. They have a very conservative approach to improving the system, and that means code that ran on Java 1.2 runs today. Code that runs on the initial OSGi versions runs today. Now, you may not care in the cloud, but you damn care in the field. You know, we're talking about we're talking about OT. We're not talking about IT anymore. The whole conditions are different. You have to be able to support devices for up to 50 years in this field. We have code running in an airplane. That airplane will be flying 50 years from now, guaranteed, you know? And you just can't take the same, well, the mode of the month is the flavor of the month is vanilla, and next work is chocolate, and we're going to change everything just because the flavor of the month changed. You can't do that in OT systems. You need that stable environment. You compare Java even to, you know, another managed language like Ruby, for instance. Try running Ruby code from 3 years ago. It doesn't work, it breaks. Or Python, you know, code that you ran 5 years ago doesn't run today because they changed the language. You need that stability, and that's a real advantage. I mean, this is the difference between engineering and art. You know, a lot of software engineers have become artists. They're not engineers anymore. They're just doing the flavor of the month, and they're re-implementing things over and over again. It's like, we don't get anywhere that way. Engineering has to be based on foundation.
We actually only have 2 minutes left, so we'll be out of here in 2 minutes. Okay, so I think I would just like to thank our panelists. I'd like to thank our panelists. I'd like to thank all of you for attending. I'll also mention, I'll mention this in the OSGi keynote tomorrow, but maybe there'll be a run on the t-shirts and socks. But we are celebrating our 20th anniversary of the OSGi Alliance. And down at the registration desks, there's a number of sizes of t-shirts that you can pick up, and we even have OSGi socks this year. So I'd encourage you all to go grab it. There's also a Birds of a Feather at 7:30 tonight. We're going to answer any questions you want on any aspect of OSGi. I'll be there. A number of our technical experts will be there as well. And yeah.
Just one final word. We have our 20th anniversary this year. And for the OSGi or the IoT space, we're going to be around for at least another 20 years. So if you put us in a device now, we're going to be there for you, guaranteed.
Thank you, Kristi. Thank our panel. And thank you all. I hope you have a good rest of the conference.